Hello and good day. We are from group 2 and today we are going to present about transfer function and Bode plot. So this is our group member Aina Shazwana, Amirul Hadi, Aiman and me Marcelina. So what is a transfer function? A transfer function is defined as the ratio of the Laplace transform of the output to the input. Here you can see from the image below, the transfer function is the output over input. In transfer function, we have 0 and pole. We can look at the image in the slide. 0 is value that make the numerator 0 and it indicates the frequency at which the system output is 0. While the pole is a value that make the denominator 0 and indicates the natural frequency of the system. There are 4 types of possible transfer function. The first one is voltage gain, which is the ratio of the output voltage to the input voltage in a circuit. The second one is a current gain. It is the ratio of the output current to the input current in a circuit. And then the third one is a transfer impedance, which is the output voltage to the input current in a circuit. And then the last one is transfer admittance. It is the ratio of output current to the input voltage in a circuit. Next is Bode plot. Bode plot are similar plots of the magnitude in decibel and phase in degrees of a transfer function versus frequency. I'm going to show you how to change a function from standard form to transfer function. So this is the given function j omega plus 10 over j omega times j omega plus 5 square. So from this given function, we don't want to change the function, so we can just multiply the function by 1. The 10 over 10 and 25 over 25 is basically a 1, so it doesn't change the form at all. So you just multiply by 1 and then at the end of the calculation you just need to divide the top and the bottom so you can get the final answer.
Hi, my name is Amirul bin Shahrudin. Okay, from the transfer function equation, now we take a look to the magnetic plot and phase plot. For a magnetic plot, first, better we will draw a gain. The value of gain is 30 log multiplied with 0.4 and we get a negative AdB for gain. So we draw a straight line at a negative AdB. Second vector is a simple 0 and the value is j omega over 10 plus 1. So at the 10 rad per second at 0 dB and 100 radian per second at 20 dB. After that, we will draw a straight line to the 10 rad per second and upward to 20 dB at 100 radian per second. So the purple line is a simple 0. Next, for the third vector is pole at origin and the value is 1 over j omega. So we plot at the 0.1 radian per second at 20 dB and the 10 radian per second at negative 20 dB. After that, we draw a straight line from the 20 dB and negative 20 dB, so the red line is a pole at origin. For the fourth vector is simple pole and the value is 1 over j omega plus 5 power of 2. So we plot the graph at 5 radian per second and at 0 dB and 50 radian per second at negative 40 dB. It is because it has a power of 2. After that, we draw a straight line to 5 radian per second and downwards to the negative 40 dB. So the green line is a simple. After draw the all of vector, we need to draw a resultant line. Firstly, we need to draw the dotted line at the 5 radian per second and 10 radian per second. We need to find a vector at the 5 radian per second and 10 radian per second and add all the value. For the 5 radian per second, the magnitude is negative 8 dB plus negative 10 dB, so we get the negative 80 dB. For the 10 radian per second, the magnitude is negative 80 dB plus negative 20 dB and plus negative 20 dB. So we get the negative 48 dB. Next, we draw the line start from 8 dB downwards to negative 80 dB and downwards again to the negative 48 dB. So the orange line is the resultant line. Next is the phase plot. First vector is scale. So the black straight line is scale line at the 0 degree. Next vector is a simple 0. So 10 over 10 we get 1. So we plot at 1 radian per second for the first plot. And 10 multiplied by 10, so we plot at 100 radian per second and 90 degrees for the second plot. Next, draw the line to the 1 radian per second and upward to 90 degrees. So the green line is a simple 0. Next, the third vector is pole at origin. So draw a red line, straight line at the negative 90 degree. Fourth vector is a simple pole. Is 5 over 10, we get 0.5. So we plot at 0.5 radian per second at 0 degree for the first plot. And 10 multiplied by 5, we get 50. So we plot at 50 radian per second at negative 90 degree. After that, we draw a straight line to the 0.5 radian per second and downwards to the negative degree at the 0 at the 50 radian per second. So the green line is a simple pole. Lastly, for the resultant line, we need to draw a dotted line at the 0.5 radian per second, 1 radian per second, 50 radian per second, and 100 radian per second. And find all vector across them and add the value of a vector. Next, at the 0.5 radian per second, we plot the negative 90 degree and for the 1 radian per second at negative 135 degree. For the 100 radian per second, we plot at negative 250 degree and 400 radian per second at 1 180 degree, negative 180 degree. So the orange line is the resultant line. Now we go to the question F. It is a dot plot to the transfer function. From the question, we need to recognize all the factors on the graph given. First of all, we need to find a gain of transfer function using a k formula. It is k equal to 10 power of 0 over 20. So we have get the value of gain is 1. Next, based on the graph, this upward graph is started at the 1 radian per second is 0 at origin. So the value of 0 at origin is 1 radian per second. After that, between 10 radian per second to 50 radian per second is constant line. And next downwards to the negative 20 dB is a simple pole. First simple pole is a 1 over j omega over 10. And the second is 1 over j omega over 50 plus 1.
So in this discussion, we learn how to draw the block plot and then how to change, how to calculate the block plot to transfer function, which is in this slide I have shown you the calculation, which is h omega in bracket equal to j omega over 10 plus 1 in bracket, and then in bracket again j omega over 50 plus 1, and then we just need to calculate it, j omega over 10 plus 1 and in bracket again j omega over 50 plus 1. We need to eliminate the 50 to make the equation become general equation, which is j omega over j omega in bracket plus 1 and then j omega plus 1 in bracket. So how we need to eliminate it? We just need to rewrite it again, j omega over, in bracket, j omega over 10 plus 1, and to eliminate the j omega over 10, that 10, we need to eliminate the 10, 1 over 10 there, we need to multiply with the conjugate 10 over 10. So when we put the 10 over 10 here, then we need to take the 10 above the 10 over 10 and multiply it inside the j omega over 10 plus 1, which we can eliminate the 10 j omega over 10, which we just eliminate the 10, and then plus 10. Then we got 1 over 10 here, and then for the j omega over 50 plus 1, just use the same method, which times with the conjugate 50 over 50, and then we got here the equation j omega over j omega plus 10 in bracket and in bracket again 1 over 10, and in bracket j omega plus 50 and in bracket 1 over 50, and then just recalculate everything, just multiply everything, and we got j omega over j omega plus 10 and j omega plus 50, and that 1 over 10 times with 1 over 50, we got 1 over 500, and then 1 over 500, we can just take it above at j omega, then it becomes 500 j omega over j omega plus 10 and j omega plus 50 in general form. And we just need to change it to transform function, which just change jw with s, I mean j omega with s. Then we got here 500s over s plus 10 and s plus 50 in bracket. That's all for me for discussion. So to conclude everything we have learned, which is we learn how to draw the bob plot, and then we learn how to convert bob plot to transfer function, and then we learn how to convert transfer function to bob plot. So first, step to convert bob plot to transfer function, which is first, identify the asymptote. Second, determine the slope. Third, identify the corner frequency. Fourth, estimate the gain. And fifth, phase plot analysis. And the second step is step to convert transfer function to bob plot, which is first, ensure the transfer function in standard form. Second, replace s with jw in transfer function. And third, plot the bob plot. That's all for me.